Okay, here's the quiz solutions. So y varies. So y varies directly as x. So k times x. Remember, don't forget k. That's the constant of variation. And inversely as z. That is it for letter A. Letter B, z varies jointly as x and the square of w. So k times x times the square of w. Not the square root, the square of w. And then letter C, x varies jointly as y and z. So k times y times z. And inversely as the square root of w. All right, for number 2, y varies jointly as x and z. So that sentence right away tells you that y equals k times x times z. The next sentence tells you that y equals 25 when x is 2 and z is 5. So this helps you find k. So 25 equals k times 10, which implies that k is 2.5. So now, finally, the third step is to find y. So by the way, this is now the official function. I know the constant of variation, and I'm going to use that to find y when x is 8 and z is 12. So it is 240. This is the answer that is required, but everything before that is just the work that supports it. Number 3, the illumination, so we'll call that I, varies inversely as the square of the distance that you are from the headlight. And I looked this up. Foot candle is an actual unit of measure. I forget what it means, but it is measure how bright something is. So the car's headlight produces 3.75 foot candles when the distance is 40 feet. So that is going to help you find K. You multiply both sides by 40 squared, and we discover that K is 6,000. That's the constant of variation. So now my function now has much more detail to it. I know the constant of variation. The illumination in foot candles is 6,000 divided by the distance squared. So how much illumination is there if you are 50 feet away from the source? So it's just as simple as doing 6,000 divided by 50 squared, and that is 2.4 foot candles of illumination if you're 50 feet away. For number 4, you go into your calculator, you run it to the nearest tenth, which is 1 decimal point. So this is 68.9. This ends up being 9.7, and this is 2.5. For the exponential functions, every single one has a horizontal asymptote. This section has a horizontal asymptote of y equals 0, but the +1 raises up everything 1 unit. So its horizontal asymptote is y equals 1. And we can actually graph this a little bit. It has a horizontal asymptote of y equals 1. It has a base that is less than 1. So this is a decay. It looks something like that. All right, let's continue. The domain for every single exponential function is all real numbers, because the domain is in the exponent, and exponents can be anything. The range is not all real numbers. The range actually is, in this case, anything greater than 1. It is an exponential decay because, again, the base is less than 1. It does have a y-intercept, which is this. If the domain is all real, it most definitely has a y-intercept, because the y-intercept occurs when x equals 0. And if the domain can be any real number, then certainly 0 is in that set. So it has a y-intercept. It does not have an x-intercept. As you can see from the graph, the function gets closer and closer and closer to 1, but it never really approaches 1. And so if it never approaches 1, it never approaches 0. And for the y value needs to be 0 in order for there to be an x-intercept. The back page, this linear function is x plus 26. And you need to use that to predict how many of these seniors apply to 3 or more colleges in the year 2010. Well, in the year 2010, x equals 30, because in 1980, x equals 0. So 30 plus 26 is 56. The exponential model, you would have to do 30.8 times e raised to the 0.0217 times 30, and you get about 59%. Well, in 2010, we know for a fact that 64%, I mean, according to this data, 64% of seniors actually applied to 3 or more colleges. And it turns out that the exponential was more accurate because 59% is closer to 64 than 56 is. How are exponential functions and logarithmic functions related to each other? They are inverses of each other. Number 8, write the log as an exponential. So this is 3 to the 5th equals x plus 2 because logs are exponents. This is e to the 1st equals e because logs are exponents. This is 2 to the negative 3rd equals 1/8 because logs are exponents. Write each exponential equation as a logarithm. Well, logs are exponents. So 2x is the exponent. That is log base 3 of 109. Over here, logs are exponents. So negative 4 is the exponent. That equals the log base 10, don't write it, that's just log, of 0.0001. Find the domain of this. Well, 8 minus x is what the log is receiving, and logs can only receive positive numbers. So the opposite of x equals the opposite of 8, divided by negative 1, we discover that x is less than 8. That's the domain. But you were supposed to give it an interval notation, so everything less than 8. Number 11, vertical asymptote. This implies a shift left of 100. And the vertical asymptote goes along. So x equals negative 100 is where the vertical asymptote is.